Hi, I'm Martha Cryan. I work in the IBM Center for Open Source Data and AI Technologies on a project called Elyra. I'll be presenting today on a generic metadata store for JupyterLab extensions. This presentation was created with the help of Kevin Bates and the rest of the Elyra team. Elyra's metadata service arose out of the need to manage disparate pieces of information to address desired functionality. Our backend service uses a schema-driven approach to validate, store, and retrieve this information through a simple REST API. To enhance the user experience, the backend service is accompanied by a front-end metadata editor extension to manage the metadata from within JupyterLab. To give you a more concrete idea of how this service can be used, I'll show one extension that uses this metadata service, and that's our code snippets extension. As you can see, the code snippets are listed in the side pane and can be expanded to show a preview of the code. They can easily be edited and created from within JupyterLab and can be inserted or copied into the appropriate file type or notebook. Each code snippet is an instance of the code snippet schema, which you can see is just a JSON file that describes the different properties of a code snippet, what's required or optional, the types of each field, as well as some other meta properties that help to describe the schema. So now we'll talk about the implementation details of this metadata service. As we just saw, the service is schema-driven. The schemas are organized by namespaces, and a namespace consists of one or more schemas. It will likely also be used to indicate storage behavior such as file system, database, and sync. This enables the ability to express a class of object through these JSON schema. From that schema, one can expect validation against the schema and CRUD operations through a REST API. Schema can specify a Python class that can be used to wrap metadata. These classes, which are derived from a metadata base class, can implement hooks for load, save, and delete operations, which enables customized behaviors. In terms of next steps, right now, schemas for each of the kinds of metadata are system-owned, but they could be extended for bring your own schema, and the same goes for namespaces. In addition, we currently use a single configurable storage class across all namespaces and schemas. As of right now, file system is used, but no SQLDB is on the horizon. We're also planning to promote namespace from a string to a class, and by objectifying namespace, it can do things like identify storage. We can also hang schemas off namespace. The REST endpoints and CLI tool take a namespace and a schema and persist instances. You also have the option to enforce required properties and data type restrictions, such as regular expressions, URIs, types, etc. Instances can be fetched and deleted within a given namespace, and the CLI tool supports retrieval of invalid instances as well, since some could become invalid if changed via outside means. Finally, I just want to show another way that this metadata service can be used, and I'm going to use this sample schema created for the purposes of this demo. You can see that it has fields like schema, title, name, namespace, and these are all just meta properties to describe the schema, but the actual fields are under properties, metadata properties. The first field you'll see is URI field that has the similar title, description, type, meta properties, and so it's described, but you'll also see a format field, and that's URI. You'll also notice UI hints as a field, and that just has category. And that's just going to describe how to format the metadata editor within JupyterLab. The next field is options, and it has similar meta properties of title, description, and type. And there's a UI hints field, which has field type and default choices in addition to category. The field type is drop down, and that's going to show up within the metadata editor with these default options. The last thing to notice about this schema is the required field, and you'll see the URI field is marked as required. We're going to see all of this within the front-end extension, but I need to move it into the schemas directory and then reinstall the backend. And once it's installed as a schema, it will automatically show up in the command palette under the Elyra category and open a browser that's auto-generated based on the schema. Here you can create a new instance of this metadata. The first thing you'll notice is that even though there wasn't a property called name under metadata, this is automatically required. Then you'll see the category that was included under UI hints for each of them, as well as the required field and an optional field. You can see the dropdown has those default choices that we saw in the schema, as well as the ability to create new options. If we try and submit it like this, there will be some front-end validation, but there's also some back-end validation that's propagated. For example, this field was marked as format URI, as we saw, and just Elyra is not a URI. So if we fix this, we can successfully create this metadata and see it in the browser, as well as edit or delete as needed. So that's the end of the presentation. Thank you for watching, and if you're interested in learning more about using or contributing to Elyra, I've included links to our documentation and our repo, as well as a helpful example for how to use some of our tools. We always welcome bug reports and suggested improvements, as well as new contributors. We also have another number of other talks in this year's JupyterCon, and they're listed here. Thanks again!